Good day, viewers. You are welcome back to the channel once again. We are going to consider questions under differentiation from first principle. So let's see how we can appreciate questions from differentiation from first principle. So now the question reads, find from the first principle the derivative of the following: y equals x squared plus 1. Okay, now what do we know? In the formula, we said the y over the x equals f prime of x equals lim as h approaches 0 of x plus h minus f of x all over h. And we were able to prove why this formula came about. So if this is your first time coming here, you can visit our previous lectures and you understand the concepts. Okay. So now, before we can solve this question from the first principles, that means we should know f of x, then we should also know what? F into bracket x plus h. When we are done, then we will now do substitution to get the answer. That's from the first principle. So I will need my f of x, then I also need f into bracket x plus h. So that's the first thing I'm supposed to find. We're given the function here, y. So y is the same as f of x. So my f of x equals what? X squared plus 1. Then I'll now have to find for my second function, which is what? X plus h equals. Now, look at something. For this formula, wherever you see x, you add plus h, x plus h. Wherever you see x, you write x plus h, because there is what? An increment. Are you okay? There is an increment. From the proving, we saw that if here is x, it increases by h. So the point here will be what? Won't it be x plus h? So this is what? The increment we are talking about. As a result of that, wherever we see x, we will increase it by what? By h. So here is x, right? So I'll write my x, then I'll increase it by what? By h, because there is what? An increment. So h, so x plus h, or what? Squared plus what? Plus 1. Now next thing is I will expand the bracket. So when I expand this, I'll get what? X squared plus 2xh, then plus what? H squared, then I'll add this, that's my constant here, plus what? Plus 1. And all this will give me f into bracket x plus h, as simple as that. So now what do we do now? I will just quote the formula nicely. I know that dy over my dx is equal to what? My f prime of x, which is equal to what? My lim as h approaches 0, bracket x plus h minus my f of x all over what? My h. So which is equal to, so I can decide to work out for this. I can decide to work out for this. So let me now look for the expression for this. So I have x, f into bracket x plus h minus my f of x over h. So let me do my substitution. What is f into bracket x plus h? From here, I have what? X squared plus my 2xh plus my h squared plus 1. Then minus, I have my minus here, minus my f of x. Where is my f of x? My f of x from the question is what? Is x squared plus 1. So I'll just come here, because it is an expression, I'll put it in brackets. x squared plus what? Plus 1. Then all divided by what? By my h. By simplification, we'll have x squared plus my 2xh plus h squared plus 1. Then I'll expand this bracket. I'll get what? Negative s squared. Then negative by positive will give me negative 1. all over what? My h. So clearly, -1 will take off +1. So I will have x squared plus 2xh plus my h squared. Then I have, this negative s squared will again cancel what? Positive s squared. So the s squared will go away. So I'll have this expression all over what? All over my h. So first of all, -1 will cancel +1. The negative s squared will cancel what? X squared. So all this will give me this. Are you okay? So by factorization, h is common, so I can factorize h out. So it will be h, then to bracket, when h divides h, I have my what? My 2x. So 2x, then plus the h squared is 2, but I have 1 here. So this h will cancel one of the h over here. So I will still be left with what? Only an h. All over what? The denominator, which is what? My h, right? So this h clearly will cancel this h. So therefore, I can now say, I have f into bracket x plus h minus my f of x all over h is giving me what? This expression, 2x plus what? Plus h. So now I'll just substitute everything over here. Now when you come here, the whole of this, I know the value to be what? I know that it has an expression 2x plus h. So wherever I see this whole expression, I'll put what? 2x plus h. Why? Because the whole expression, you see, you can see it from here, is equal to what? 2x plus h. So I'll do justice to that. So now, finally, I have my dy over my dx, which is equal to my f prime of x, which is equal to my lim as my h approaches 0 of f into bracket x plus h minus my f of x all over h is equal to, you know that this is the same as, I have my lim, and I have h approaches 0. Now wherever I see this is the same as what? This expression over here. So I'll write 2x plus what? Plus h. But please note over here, we are saying that h approaches 0. So now wherever I see h, I'll put the value of h to be equal to what? To be equal to 0. From the first principle, the formula that we proved, realize that as scale is approaching p, h will gradually what? Decrease to the extent where h will become what? 0. So we'll put 0 in place of what? Of h. So this is the same as what? 2x plus what? Plus 0, which is equal to what? My 2x. So this is what? My differentiation from the first principle. As simple as that. Follow me for more catchy and interesting videos on differentiation from first principle, where I'll give you another alternative to solve similar question. So just ask yourself, just in case you have forgotten the formula, this whole formula you have forgotten, what other alternative method do you have? So that is method, can't you proceed? So you just follow me up for the next video and I'll bring you the alternative method. Bye bye.